In the last video, we watched as AI engineer from Google, Yufeng Guo, ran us through the 7 steps that are required to solve a business problem using machine learning. They involve gathering the data, preparing it, choosing a model, training, evaluation, hyperparameter tuning, and finally prediction. In today's lesson, we will dive deeper into the techniques. Specifically in this video, we will run through some of the supervised learning techniques, which are seen on the left-hand side of this slide. So we have regression, decision tree, random forest, and classification. What we will be running through are regression, as well as classification and decision tree. Do note that decision tree is a subset of classification. That's why trees also appear here. The second thing to note is also that when actually asked whether a certain, like for example, image recognition, is it a supervised technique or a classification technique, the answer should be classification because it is a more appropriate answer. Let's begin with the most basic of supervised learning techniques, regression. What we want to do using regression is to predict a dependent variable using one or a number of independent ones. For example, what are the factors that determine your score for this module? In this example, the dependent variable is what would you actually score eventually for this module. And the factors that affect that would then be our independent variables. What are some factors you can think of? Manage to identify any? The ones I could think of were things such as the amount of time that you spend studying, or it could be the amount of games that you played, or the amount of time spent on social media. All of these would have a bearing on your final score for this module. Secondly, another example, what do you think are the factors that determine the price of a HDB flat? What do you think is your dependent variable in this case? Manage to find it? It would then be the price of the HDB flat, while the factors that determine it are our independent variables. Some of these factors could be things such as the floor area. The bigger the flat, we would expect that we will pay more. Or, depending on certain locations, flats in the central area might command a higher price. So that's what we hope to achieve using regression. So this is a visual representation of a regression graph where we are using study time to predict the kind of grades or GPA that you will get. So here we see that the line is sloping upwards, meaning there is a positive relation, meaning that as you study more, you will realize that you will get a higher grade. If you study little, you will get a worse grade. So this is an example of how we use regression to make a prediction. So for example, if someone in the class told us that, hey, I studied 5 hours for this test, and if 5 hours hypothetically is this point, we can actually draw a line up and to the left to identify what exactly would be his or her grade. Next, we look at the machine learning technique of classification. So here, classification, we are trying to distinguish between two types of values. So in the graph that you see, we are trying to distinguish between the circles and the crosses. And this line that is drawn in red is what separates the circles from the crosses. And as a definition, they are problems when we are training a model to predict qualitative targets. For example, gender or a type of fruit, meaning that they are categorical values that these variables can take. So in the case of gender, it could be male or female, and in the case of a type of fruit, it could be an apple or an orange. So circles could be males, crosses could be females, or circles could be apples and crosses oranges. So what are some situations where classification could be useful or helpful in your field of study? I'll give you a moment to think about it now.
Manage to think of any? One example I can think of is to determine whether an employee is likely to churn. For those of you who are interested in the area of human resource, this might be a problem that interests you. In this case, churn means whether he is likely to leave the company. So churn equals leave, not churn means he will stay with the company. So let's take a look at how decision trees can help us with this classification problem. Before we begin, let's think about what are the possible results. The result could only be either he decides to churn, meaning he decides to leave the company, or not churn, where he decides to stay with the company. So here we ask a series of questions. Did the employee receive a promotion recently? If the answer is yes, then we ask, did his or her partner change job recently? If the answer was also yes, then he is likely to leave the company or be on the lookout for a new job. But if the answer is no, then that is where he is unlikely to leave the company. If he did not receive the promotion recently, has he been with the firm for less than 5 years? If he's been with the firm for less than 5 years, then he is likely to be on the lookout for another job. If not, then he is likely to stay with the company. So this is an example of a situation where we are trying to determine if a or employee is likely to churn or leave the company. Let's take a look at a demo for a decision tree. So in this demo, we are trying to identify what kind of car is suitable for a particular individual. So in this example, we first ask what kind of income this person earns. So if this person earns a fairly high income, then we start to ask, does he have kids? Does he more than two kids or just one to two kids? So if he has more than two kids, does he want to spend a little or a lot on a car? And if he wants to spend a lot for someone with this profile, fairly high income, more than two kids, and willing to spend on a car, then his choice would then be likely to be a van. So a decision tree essentially asks a series of questions to determine whether the outcome is likely to be a yes or a no, or in this case, what kind of car he or she is likely to purchase. So that brings us to the end of the supervised learning techniques. In the next video, join me as we explore the unsupervised ones. See you. Thanks.